Hey everybody, this is Larry. This is day 2 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get started. So usually I do this live, so if I don't get the explanation right away, you always know why. Contains duplicate 3. Given an array of integer, find out whether the two distinct integer I and j such that the absolute difference between I and j is at most t, and the absolute difference between I and j is at most k. Oh. Okay. So, how is that duplicate though? That's a very confusing name. But, so if k is equal to 3, and t, what is t again? T is 0. Okay. So t is the, I don't know, they wrote it in a different order, so it's a little bit confusing. But so I mean, I think the way that I would think about it is using a sliding window on a sort of a binary search tree type structure, so that we get it in n log n. I think that's probably all you have to do, because so basically my idea is that, okay, so you have a sliding window, right? That so that you keep was it k? So you keep k elements in it, or maybe k plus 1 element in it, or you just keep k element in it, and then for each number that you pass in, you check. You do a binary search on whether that number is in it. If not, then you just look at the number that's smaller than it and the number that's bigger than it, and see if that's between the absolute difference is inside t. And if you keep the sliding window, then it's going to be like technically actually log k, so it'll be n log k operation every time, and log k operation every time for each element, so then it'll be n log k roughly. So that's the thing that I'm going to go with. The actual implementation, so that's the algorithm, right? So now I'm just thinking about the implementation. In Python, in some languages like C++, there's a set. In Python, there's a thing called sorted containers, which I think I'm going to use this for. The only nuance here is that, and I might doing some kind of hack here as a result. The only nuance is that so in sorted containers and in binary, and even in C++, you do a binary, there's bisect left or something like that, or bisect right or something like that. But basically, it gets that number or the bigger number, right? But in this case, we actually want to do two searches, if you will. You want to search the smallest number that is bigger than this number, and the smallest number, the largest number that's smaller than this number, right? That makes sense. So basically, for example, in this case, if we have the number 1, we want to get the two numbers that are closest to 1, both on the larger side and the smaller side. And that's kind of how I'm trying to think about it in terms of how the implementation. And I'm looking right now at the documentation for sorted containers. I think sorted set is maybe okay. Or we could use sorted dictionary to just keep track. And I think that's probably good enough, I want to say. Yeah. Because we'll just keep track of almost like a counter kind of thing, right? So yeah, so I'm gonna do a little bit and just take a look at the hint first. Okay, that's exactly what we said, and yeah, okay. So basically, it's just what we already said. So that makes me feel a little better. Though I thought that would be good enough. I just didn't know if there'll be a more optimal solution per se. But yeah, so now let's import. I never remember if Leetcode does this for us automatically, but so it's it's good to have it. So we want to actually let me do this. And so I actually want to do two things for to answer the questions that we have in terms of implementation detail. As we said, we want to get the larger number and then the smaller number as well. But the API will only give us the equal or bigger number, right? So I'm going to create two dictionaries, one for the greater and one for the smaller, and just do some do some math on that, and that should be good enough. Okay, now that's for x in nums. Let's just call something like count is equal to 0, right? And then for x is nums, okay, let's just have two sorted away or sorted dictionary. In case you're wondering, I'm just looking at the API for sorted containers. I just basically here, if you want to see it, because so that is one thing that Larry is trying to get better at it, as well as just learning sorted containers, because I don't know, people keep on telling me about them. So so yeah, okay, so I just need to so we want to add x in there. Well, before we add x in there, we do a search if bigger dot is it bisect left. So I think dictionary has some like weird thing. We'll see. So we'll learn this together. What does this give us? This should give us the key, right? So I remember that this actually gives the index, which is kind of a little bit awkward, but can we click through this? Yeah, definitely. If you're thinking about doing this at home, do whatever you feel is comfortable to kind of just figuring how to learn, right? And I think that's the most important thing. Return the index. I could have sworn that what is this? I forget how to do this actually, because this gives you the index, but is it just dot keys of the index? Okay, I think that's how you do it, but it's a little bit the syntax is a little bit awkward, but okay. So index is equal to, and what if it's not in there? Do we left with anything? Oh, I guess it just goes all the way to the right, right? So okay. Okay, I think I have enough to at least go on. Okay, if bigger index is greater than length of bigger, then well, if it's less than, I guess is what we care about. Then we check bigger dot keys of bigger index. So yu is equal to, if yu is or we could just do absolute yu of yu minus x is less than or equal to, is it k or t? T. return true, and then we do the same thing for smaller index. Except for we want to do the negative version, because then all the keys will be inverted as well. Oh, this would be in the negative. So, okay. So I think this is good. And then now we insert the key. Now insert x. Right. So let's do count is equal to 1. Bigger of x. I think we can do. Maybe I have to do a check because I'm thinking. Actually, not sure if it automatically generates it. So let's if x. How do I add, and is there a discard? Oh, but that's for sorted list. How do I add in? Why is there a pop item? Pop item index. I really don't know how to use this, but how do I just like remove item? Okay. Oh, del. I guess that makes sense actually. Not in bigger. Bigger 0. And then also if x not in smaller, negative x is equal to 0. Negative x 1. And then now if count is greater than t, is it? Then we have to remove some from the index. So actually we need the index so that we could do the math. Previous index is equal to index minus t, and then now we want to remove it from bigger. Previous value is equal to num sub previous index, and then previous value to do 1. If this is equal to 0, then we should just remove it. Same thing for the smaller. Can't type though. Okay, so I typed a lot, probably more than I would like for testing. And then at the very end we just return 4. So let's give it a go. Yeah. Probably should put in all these other ones as well. That's not good. Not a great sign, but that's okay. I think we have to algorithm that's right, so it'll probably be some weird or maybe not so weird implementation thing, which is always an opportunity to learn. Alright, do we just get force all the time? Oh, we actually get, that's maybe we have an off by 1 somewhere then, but that's okay. Okay. Oh, I guess I guess technically but I don't think that changes anything. But what we actually want to do is maybe how do I want to debug this? Okay, let's do something here with print bigger x bigger index smaller index. So these are all zeros, so that's not great. Would it have to be 0? Well, well, that's definitely true. So that means that in this one it should return true, but it's returning 0. I don't know if maybe land or bigger and smaller. I don't. That's the one thing that I actually don't know about. So can't imagine it be that, because that's just a number of keys. So yeah. Oh, do we never insert? How come we don't insert after this? Okay. It's either that or... maybe my syntax is wrong. No, there's always one. But then, do I have T wrong? Oh, I mixed up K and T. So this is K. Okay. That's just maybe a silly typo then. Okay, so now, okay, maybe that was just a silly typo. Like I said, I mixed up K and T, and then I end up mixing K and T. What other edge cases are there? Let's just try one, maybe. And yeah, I mean, as I do on stream, especially live, I'm a little bit lazier, so I will submit because I could get test cases that way. But I definitely urge that when you're at home, definitely practice thinking and coming up with test cases and try to get it right on the first try, because you know you don't want your interviewer to tell you about it. Did I miss that? Yep. Oops. That was just a silly typo. I didn't know negative would be a thing though, but yeah, because you don't want on your interviewer to be like, hey, are you missing anything? That means that you're already a little bit sad. Like I am a little bit sad right now. Okay. So this is 4, so maybe I went off by 1 to 2 and 3. That should be... which one is 2 again? 2 is K and... Okay. So that's actually a legit wrong answer that I will have to try to debug. Yeah, also this typo was bad though, but I always forget which one's K and which one's T. So the index is at most 2, so that means there should be 2 things in it. And yeah, maybe I don't look up the smaller correctly. I think that's the thing that I wasn't super sure about. So let's take a look. And again, you know, I think you should come up with these test cases yourself. Yeah, I mean, there's no really excuse about it. Oh. Oh yeah, I mean, okay. -1, right? Yeah. Oh, this should be -x. I think okay, well that still didn't fix it, unfortunately. This should give us -1, right? Okay. Unused thing, yeah, okay, fine. This gives us 7, really? Oh, that's why we don't need this X bit. But why is the bisect left give us the Let's see. Again, so I am doing this live, so apologies for technical difficulties. Okay. But why does the 3 matches to 7 with -3? Doesn't it go to the -1 as the thing? Or am I... did I misunderstand? Oh, what? Larry, come on. Larry! I didn't even copy and paste, I typed it out. I just kind of mentally copy and paste, I suppose. Let's try again. Okay, cool. So I mean, I think just looking back, what could I have done better? Probably better abstractions. If I had better abstractions, then like a lot of the things that my couple of wrong answers that I had was just basically. I mean, I typed them out, so it wasn't a copy and paste error, but it was just a mental error in the typing. The algorithm was actually pretty good, and the flow was right. And so yeah, so it's one thing that I would think about is just having the proper abstraction, because everything here is the same except for it just has a different thing, and that kind of threw me off for way too long. And I just have, I don't know, I just have different things in different places, but otherwise, yeah, pretty fun problem. I think you just have to kind of ask yourself the question each step of the way of how do I get it, and the sliding window will come in place because you only care for each index. You only care about the last T index or no K index, right? So that's how I come up with the sliding window. Yeah, and the reason why I did a sorted dict, or you could use a set in C++ or Java or something like that and use a binary search, is because of that reason, is that you want to get a logarithmic time query for each thing. So again, sorted dictionary is going to be linear space. For me, it's linear space times 2. I use a little bit of a hack by using 2 dictionaries to do search on both larger and smaller. You can maybe figure out ways to do it a little bit differently. And for each item, we do log n, log k operations. So this algorithm is going to be O of n log k time complexity. Yeah, that's all I have for this problem. I'm going to keep on solving these for the rest of the month. So hit the like button, hit the subscribe button, join me, and let me know what you think about this problem. Again, I had a lot of typos, but otherwise I got it right pretty much on the first try. I mean, it's a consolation. I mean, I really should have testing to kind of test it in any case. But yeah, wow, I don't know how my testing didn't catch a few of these, but sometimes it happens. Yeah, let me know what you think, and I will see y'all tomorrow. Bye-bye.